So let's take a look at the concept of relations, and more specifically, we will discuss functions. So first, what is a relation? And a relation is just simply any relationship that exists between two sets of values. So in one set, we will have what's called the domain, and then we have those values to which those elements are assigned, the range. So every element in the domain is assigned to at least one element in the range. So what does this look like? Imagine that we have a set of values, we'll call the domain, and then we have another set of values called the range, and we have values in the domain that are assigned to values in the range. So let's take a look at an example. Here we have a relation, and we have values in X, A, B, and C, and A, for example, goes to 1 in the range. B goes to 2 values. It goes to both 1 and 2. C likewise goes to 2 values in the range, 3 and 4. So what is the domain? The domain is the set of values that get assigned to Y values. So A, B, and C are all assigned to 1, 2, 3, and 4. So the domain is the set, and we use curly brackets to denote a set, remember. So A, B, and C are the domain. And then the range are the values to which these are assigned. So 1, 2, 3, and 4. You can almost think of the domain as the input and the range as the output. So the range is 1, 2, 3, and 4. So here we have the relation set up as a set of ordered pairs. If it helps, what we can do is we can write this as a table. So we have X values and say Y values. And so 5 is an X value, and the corresponding Y value is 2. In the next ordered pair, we have 3 goes to 3, 1 goes to 7 in the third ordered pair, and then 9 goes to 3. So the domain is the set of all the X values in the ordered pairs. So the domain is the set, and I'm going to write these in order. You don't have to. 1, 3, 5, 9. The reason why we don't have to put them in order is because we're writing them in a set form, which is designated by the curly brackets. And in a set, order does not matter. If we were writing an interval, then it would matter. So the range is 2, 3, and 7. So what is a function? A function is a special type of relation, and it's a relation in which every element in the domain is assigned to exactly one element in the range. So each X value goes to exactly one Y value. So here we have a relation. Notice finance, maintenance, and purchasing consist of the domain, and Terrence, Joseph, Cynthia, Saeed, and Jennifer consist of the range. So does this represent a function? Now, for it to be a function, every single element in the domain must be assigned to an element in the range. And moreover, it can only be assigned to exactly one element in the range. So if you look at finance, finance is assigned to 2 elements. So we automatically know this is not a function. We have to explain why not, and we simply have to say that finance is assigned to more than one element from the range. We just need one example or one counterexample to show that it's not. Or you could just simply say there are elements from the domain that are assigned to more than one element from the range. We don't have to be specific. I like to be specific, though, whenever I give my counterexample. Okay, so here we have a set of ordered pairs. It might be beneficial to write these as x values and y values. And instead of writing them in a table format, we have 1, 2, 3, and 5 are the x values. And then the y values that we see are 2, 3, 4, and 6. Let's draw an arrow diagram like what we saw in the previous example. 1 is assigned to 2, 2 is assigned to 3, 3 is assigned to 4, and 5 is assigned to 6. Now, are there any x values that are assigned to more than one y value? No. So therefore, each x value is assigned to exactly one y value. So this is a function. So now let's do the same thing for this example. We have x values and we have y values. The x values are 1 again, I don't need to rewrite that, 3, and 5. The y values are 2, 9, 8, and 7. Notice 1 goes to 2, 1 is also assigned to 9, 3 is assigned to 8, and 5 is assigned to 7. So is this representative of a function? No. Why not? 1 is assigned to more than one y value, or to more than one element from the range. So now try this one. We have x values and y values. Go ahead and put them in a table format. 2, 3, 4, 5. And our y values are only 1. There's no need to repeat that. So let's draw our arrows. 2 is assigned to 1. 3 likewise. 4 likewise. 5 likewise. So the question is, does this represent a function? Reread the definition and make your determination. So I suggest pausing the video now, reviewing that definition, look at the previous examples, and see what you think. Come to your conclusion, and then unpause the video and see if we agree. So for this to be a function, each value in the domain must be assigned to exactly one value in the range. So let's go piece by piece. This is an element in the domain. Is it assigned to exactly one element in the range? Yes. 3. Is 3 assigned to exactly one element in the range? Yes. So on and so forth. 4 and 5 likewise. So is this a function? Yes. It is a function.